Moving forward, the next session is all about AI meets Kubernetes. Mr. Saiyam Pathak, Principal Developer Advocate, LoftLabs, will be conducting this session. So everyone, please get ready for another informative session. AI meets Kubernetes, architecting GPU infrastructure with isolation and efficiency in mind. But before that, let me give a small brief about sir. Mr. Saiyam is working as Principal Developer Advocate at LoftLabs. He is the founder of Simplify, focusing on simplifying cloud native and Kubernetes technologies. Previously at Civo, Walmart Labs, Oracle, and HP, Mr. Saiyam has worked on many facets of Kubernetes, including machine learning platforms, scaling multi-cloud, and managed Kubernetes services. He has implemented Kubernetes solutions in various organizations. When not coding, Saiyam contributes to the community by writing blogs and organizing local meetups for Kubernetes and CNCF. He is also a CNCF tag sustainability lead. With this, everyone, let's welcome our next speaker on dais with some energy. Everyone, let's please put your hands together.
All right, so here we are trying to understand AI meets Kubernetes and architecting GPU infrastructure with isolation and efficiency in mind. Too long, but we'll simplify all the terms that are there on the screen right now. So yeah, a bit about myself, Principal Developer Advocate at LoftLabs. You can connect with me on LinkedIn. I think that one is LinkedIn. This one is my YouTube channel. And I'm CNCF Tag Operational Resilience Chair as well. So what is happening? AI is on the rise. We all know that. Like, people have been going crazy since ChatGPT came out. The number of models that are coming in, every night you sleep and tomorrow morning there's a new LLM out there. And 2025 has seen the rise of agentic AI. Like, people have gone crazy, like how to build AI agents, we'll fix this problem and we'll do this, do that. In the end, what is happening is the GPUs, manufacturers like NVIDIA and GPU manufacturers, they are rising, they are creating more and more GPUs, more creative architectures like DGX. And with that, the complexity is increasing, the AI use cases are increasing, and the GPU demand is increasing as well. So that's the current kind of ecosystem that we are living in. And it's only going to increase from here because the model maturing is not happening downwards, so it's getting more and more better. You have seen VO3 is creating more realistic videos. We'll be having more and more creative stuff coming out of these models. What do people need, or what do we need as an enterprise or as within an enterprise? There are a lot of things that is needed. Specifically, we need infrastructure that can scale. So our infrastructure, the current infrastructure, should be capable enough if our team wants to build on those AI use cases. Then batch processing, because Kubernetes, the machine learning, the whole life cycle, going in from training to the inferencing phase, there are a lot of phases in that particular life cycle, and the batch processing is needed. Resource management, the efficient resource management of GPUs, specifically of GPUs, is really, really critical and crucial because they are expensive, very expensive. Like very, very expensive. Then MLOps, how to tie into the buzzwords of DevOps and include machine learning also over there and create the whole pipeline life cycle and keeping the machine learning engineers happy, which is very difficult because they know only about training models, they know about inferencing, they know about writing applications, but they don't care about the infrastructure. They don't want to care, and as ops engineers, that's the bridge that has to be created. Like MLOps has to be the bridge, so that they should not care about what Kubernetes, what that is. They should be able to just run their workloads whatever environment that they are getting. It should be easy. Training and inferencing, the whole process streamlined, and AI infrastructure for the teams. This is one of the key areas because when you talk about an organization, AI is not done by a single person. There are multiple teams working on multiple use cases because this is something people are trying and testing. Like which certain thing will fail, which certain thing will pass. So multiple teams are experimenting at the same time on different set of use cases. Now, how do we cater to such teams within the same organization and give them and provide them the infrastructure? So, Kubernetes is basically a container orchestration system. If anybody doesn't know, it is for orchestrating the containers, and actually with the modern ecosystem you can orchestrate, with cross-plane and KubeVirt integration, you can orchestrate VMs and whatnot. But why it is critical today? Because of these companies using Kubernetes in their production environments. So OpenAI actually gave a keynote at KubeCon where they have this statement as well. They scaled the Kubernetes clusters to 7,500 nodes, producing a scalable infrastructure for large-scale models like GPT-3. So the model that came out that people went crazy was actually trained on Kubernetes. So that's why, and that's how important this particular system is, this piece of technology is. So AI workload lifecycle with KAIDs, we want from all the stages, develop, train, deploy, serve, monitor, everything with a single platform. And we want to create a robust platform that, let's say people call these days them fancy terms like platform engineering, platform teams. But what we need is, we need a platform within the organization that is able to cater to the CPU needs, to the GPU needs, to different set of teams with ease automation. So the trend is on the rise of bringing GPU into bare metal Kubernetes setups. Now the term bare metal is important over here. Why? Because when we talk about LLMs, there is always a concern of security. Like everyone wants to keep their data local to themselves, because there are healthcare providers, there are fintech providers, but they still want to use the power of LLMs, the open source LLMs from Hugging Face. So how do you do that? The best way is to buy some infrastructure from NVIDIA and put them in your data center and then have your data locally. So that's what many organizations are doing. They are bringing the GPUs to the bare metal infrastructure that they are having. So now how do we cater to those workloads? Like how do we exactly make them work, or what people are currently doing, and how we can, what are different architectures that can be followed? So currently some of the challenges are the namespace, the tenancy challenges that we'll try to solve. So one of the challenge is limited tenant isolation. In Kubernetes there is the concept of namespaces. Namespaces provides you with certain level of isolation, but it doesn't give you that level of security, that level of flexibility that you can hand it over to your tenants as full-fledged clusters. That is difficult. Restricted tenant autonomy. So you cannot install your own set of tools which restricts the tenant, and that also increases the overhead on the platform teams. Complex compliance requirements. So weak isolation regulatory and compliance challenges, particularly for the enterprises with strategic needs. For example, if you need some policy engines to be deployed, how do you do that? Operational complexity and cost. So cost is obviously something which is there, like which I'll talk about, like the architectures. So what is the current architecture? Current architecture is, I have ordered, or your CTO has ordered a few machines, CFO has ordered a few machines from NVIDIA, and they have plugged into the data center, and now as per him, we are ready for the AI workloads. And as an operator, as an infrastructure person, you provision the Kubernetes cluster, you attach those GPU nodes, you create a NVIDIA, you provide the NVIDIA GPU operator on that, you start creating the pods. So far so good. Let's try to understand what the problem is. And the problem is, the first problem is that the scheduler of Kubernetes isn't itself very efficient, or was made for these AI intensive workloads. The Kubernetes scheduler was made for regular workloads, which is why there are a lot of projects. One of the projects is by NVIDIA itself, which is open source, called Kai Scheduler, which is very highly optimized scheduler for the machine learning workloads from training, inferencing and whatnot. And also like it lets you get those fractional GPUs using Kai Scheduler, and you can assign that to different set of nodes and stuff. That is current architecture with Kai Scheduler. Now what happens when different teams need Kubernetes clusters, but because they have different use cases? Okay, the infrastructure provider says we have 4 GPUs. What we'll do is, instead of one Kubernetes cluster, let me create 2 Kubernetes clusters and hand it out to 2 different teams. Now one of the team is using the GPU node not very well, which is bad. One of the teams is using too much of the GPU, which is also bad. And the third case is tenant C and D, they are still waiting to get GPUs. Now, how do they get? And they are still waiting for a new Kubernetes cluster for them to be provisioned or the hardware to be coming in, when they know that there can be certain workloads, there can be GPUs that can be used from another team, but they cannot because they don't have access to it. So, how about a shared cluster, but using the namespace based concept? Like, let's have all bare metal infrastructure, let's create everything, let's create a full Kubernetes cluster from it, attach all the GPUs over there, install Kai scheduler, install NVIDIA operator over there, and then create namespaces. What happens is, this is a non-autonomous process, and you have to manage those namespaces yourself. You have to give access to the namespaces yourself. You have to create network policies, network restrictions, resource quotas, roles, role bindings. You have to, then how do you automate multiple namespaces for a particular tenant? So that becomes a challenge. This is where the solution that we propose is vCluster. vCluster is the open source tool out there that lets you create virtual Kubernetes cluster on top of your existing Kubernetes cluster that can be anywhere, bare metal, AWS, GKE, EKS, anywhere. This is the architecture looks like. So you have the host Kubernetes cluster, which is your bare metal Kubernetes cluster. Now you create the tenants. Let's say there was team A, team B, team, like we'll actually go through that. Now what happens is, we have a single cluster, but instead of the namespaces, what we have done is we have created virtual clusters. So team A gets a virtual cluster with its own kubeconfig file, and when they do kubectl get pods -a, they see only a single core DNS pod. They do not see anything else. Nothing from the cluster which is there on cluster B, nothing from there what is there on the host cluster, and they can deploy whatever they want to. They can do kubectl run nginx -image nginx to run a pod. They can create a deployment, they can install cert manager, they can install Argo CD of their choice, they can install custom resources of their choice. So they can install anything of their choice in that virtual cluster. Since all of the GPUs are in the same pool, so it becomes easier for whenever there is a workload to whatever Kai scheduler picks, and whatever we are sharing, it will automatically go to that particular GPU node if it's a GPU workload. And interestingly, you can also attach GPU, CPU node, and different set of node pools, and then do those workload scheduling. So how it looks like in the data center, this is what I told you. You have your physical servers, then you have your nodes. Now we also have another project called vNode to allow privileged pods to be created by the virtual cluster admins. Because what happens is, when there is a container breakout, we always talk like keen to know about the security aspects. Whenever there is a container breakout from a privileged container and you go to the node, you will be able to see the contents and the file system of the real node. In order to save that, what we have is, we also have a product called virtual nodes that can help you virtualize those nodes. But even if you do not care about that, the virtualization stack that we recommend is, obviously you have bare metal, you have your Kubernetes layer, on top of that you have virtual cluster. So another mode, that was the shared tenancy mode. We also have another mode called dedicated mode, where you can use node selector. So you can have a dedicated node pool of CPU, you can have a dedicated node pool of GPUs, you can attach both of them inside the same cluster and label them, just using the regular Kubernetes concept of labeling the nodes. Now when you create, you say that the vCluster A will go on the nodes that are having the label A, and vCluster B will be going on the nodes that are having vCluster B. What it helps you with is, you can specifically direct your workload or your virtual cluster to go to this particular node. Now the workloads that you run on this particular workload, this particular virtual cluster, will be on the node. Now there were some, so I had a lot of great conversations outside. There were some conversations and very good questions that I would want to cover over here. When we talk about virtual cluster, what do we need? We need a base cluster. Your base cluster, now think about, you got your hardware. You got your hardware from NVIDIA, IBM, whatever that is. You have hardware in place. You install Kubernetes on top of this. So you have the host cluster Kubernetes. Now you create those virtual clusters. Now these virtual clusters are given to different teams as kubeconfig files. All of these people are logging in, like they are doing kubectl get pods, run, deploy, whatever they are doing on their virtual clusters. every virtual cluster has its own control plane that is running as a stateful set on the host cluster. I'm happy to give a demo as well outside, but that's how the whole concept works. We also have something very interesting which is coming up. So the multi-tenancy ecosystem is broad, like it goes from soft multi-tenancy to medium multi-tenancy to hard multi-tenancy. And in covering the entire spectrum, the main goal of vCluster is to cover the entire multi-tenancy spectrum with the same user experience. So we have the namespace level isolation, we have the vCluster shared cluster isolation, we have the dedicated node selector. The next thing next month that we are coming up with is called dedicated clusters with private nodes. So what you can do here now is you can have a virtual cluster, but you can attach different nodes with different CNI, CRI and CSI to this particular node. So usually in the regular stack, the virtual cluster will be sharing the same networking stack from the host cluster. But in this particular case, your virtual cluster lives on a host cluster and you can connect different nodes from different providers or with different CNI and the networking, different stack basically. These are some of our customers. So CoreWeave, Atlin, Ada, GoFundMe, Abby, and also leading banks are also the customers. Aussie Broadband has a very good case study which is published on our YouTube and even on the Cube YouTube channel. So a lot of case studies are there. It is being used in production with a lot of customers there. And yes, we also have a booth. So I don't know the swags are there or not, but yeah, we do have a booth. Feel free to drop by the booth, look for the orange, and happy to answer any questions if there are. And also, since vCluster is open source, so vCluster open source has its own community, and it's also Apache 2 license. So vCluster open source is the tool that you can go and use today. Now we also have an enterprise tool like vCluster Enterprise that has additional set of features that you can go with a license based model. But to get started, to do whatever I just showed, like having a bare metal, or if you don't have a bare metal, then having a EKS cluster or GKE cluster, and then if you want to virtualize, or even if you don't want to spend anything, open your laptop, install Kind. If you have a Kind cluster, Kubernetes in Docker on your laptop, you install the vCluster CLI, you do vCluster create demo, it will slice the Kind cluster and give you the virtual cluster on your Kind cluster. So you can try it out locally first, then you can try it out on your managed environments, then you can try on your bare metal servers and see where it fits. Obviously, the model that we say is instead of control plane, instead of cluster per tenant, go to control plane per tenant, because every virtual cluster is coming with its own control plane, which is why there is no overhead attached, like there is no overhead on the host cluster, because anytime you do connect to a virtual cluster, you are calling the API server of the virtual cluster and not the host cluster. So that's how the virtual cluster works, the virtualization layer works, and we covering the entire multi-tenancy spectrum is what we are here to showcase. So happy to meet you all, and you can schedule or book a demo using the link vcluster.com/enterprise demo, slack.vcluster.com, and in general, if you go to vcluster.com, you will be able to see the quick start but on the top right, where you will be getting the commands to install on your laptop and just get started and play around with it, how it works. There is no license, nothing required for that. If you have to use enterprise version, then you ask for a free trial, which is also free for 14 days, that you can try out and see where it fits with your particular use case. So yeah, that's pretty much it that I had with respect to vCluster and how the modern AI infrastructure looks like and what it should be if you are building one on your data centers. Thank you.
Thank you so much, sir. Please be with us. May I invite Ms. Rupali Gupta, Global Director of Platform Engineering. Ma'am, can we have you here on the dais, please?